Welcome, everyone, to the closing ceremony of the Generative AI Innovation Incubator. I'm so pleased that we have made it this far. It's been a journey this summer. We've had many events together, lots of conversation, and we have exciting things to share for this event, the closing ceremony of the summer. I will say, just as a heads up, that the Generative AI Innovation Incubator will not be ending. We will be taking a break, but we will be coming back with some events in the fall. And so keep your eyes peeled. We'll be starting up some new events in October. And I'll talk a little bit more about that later. So just as a few words about what we've been doing with this set of activities this summer, our goal has been to start a conversation, to bring multiple voices around the table, and to really counter the hype and fear that we often see in the media, and to bring experts and anyone with questions together to talk and reason together. And the idea was that we started out with some panel discussions to get experts in different impact areas together. And we had long QA sessions, we had invited talks, we had tutorials, and then finally the hackathons were ways that community members could work together on projects and really explore what's actually possible and what's hard with generative AI. And we had 3 hackathons, and you will hear from the winning teams here and see what it is that they did, and also what they learned and what message they have to share with the world. And those will be sandwiched in between 2 keynote talks, one by Jaime Teevan and the other one by Mona Diab. So here's the schedule of today's events. We're doing the welcoming now, and then Jaime Teevan will give her talk on From Documents to Dialogues, how LLMs are shaping the future of work. So she will speak, and then we'll have some QA. Then our 3 winning teams will present, and that's Chat TA from Education and the Future of Work is a theme, Health Advisor from Medicine and Public Health, and Sustainable Investor AI from Finance and Economics. And then finally, we'll have a keynote talk from our new director of the Language Technologies Institute, Mona Diab, and she'll be talking about responsible generative AI in practice. And that will wrap up today's session with some QA and a few words about next steps. So we'll start with Jaime Teevan. I'm so very pleased to have the opportunity to introduce her. She came highly recommended as someone who could speak on behalf of the impact of generative AI on the future of work. She's a chief scientist and technical fellow at Microsoft, where she's responsible for driving research-backed innovation in the company's core products. She's an advocate for finding smarter ways for people to make the most of their time, and she leads Microsoft's Future of Work initiative, which brings researchers from across the company together to study how the pandemic has changed work. I'm so excited to turn the mic over to her now, and so I will stop sharing my screen. And Jaime, we are ready for you.
Awesome. It's a pleasure to be here, and thank you, Carolyn, for organizing this. It's been a great series of talks that you've had, and it's awesome to see the hackathon winners as well, and all of the hackathon projects. I'm going to lean a little into that topic, that's future of work and education, from the perspective of being inside of Microsoft, where we're really thinking a lot about how work practices are going to change in light of large language models. And one of the things that I've noticed looking at the different talks that you've had over the course of the summer is that everybody starts with a little bit of a historical perspective. And I'm going to do that as well. And I think the fact that people are doing this represents what a significant shift we're in the middle of. It's almost impossible to really understand it without understanding it in that larger context. So This slide represents a little bit of the historical trend of technology and its impact on GDP growth. Historically, technology has been a GDP growth multiplier. You see it, for example, we see a 4 times growth in the 1800s all the way up to 20 times growth in the last century. And that growth is only accelerating. There's this great quote from the CEO of Shopify that I really like, that is, today has been a great year in AI. And that's often how it feels. Something that just happened yesterday feels like forever ago. And tech spend has grown faster than GDP for the last decade, and AI is really going to be sort of the next leg up when we think about economic growth. And one of the great things about this series and the hackathons and all the things that people are getting engaged is that, when you look back at tech trends, we're really an observer and we're trying to understand them and see what they look like. But when we look forward, we're responsible for shaping them. Like, we're the ones who determine the impact it has and what that looks like. And so I really appreciate everybody who's here leaning into that and taking responsibility for the big shift that is underway. So our CEO at Microsoft, Satya Nadella, likes to situate this current moment actually in research, which I think is pretty cool when, if you think about us as computing technologists and computing researchers, the fact that it is that the research that's happening is so important. So he talks about Vannevar Bush and the Memex and what that was like to think about capturing and making sense of all knowledge. And he talks about Doug Engelbart and the mother of all demos. I'm going to, just given I know there's been a lot of conversation about the history and there's a lot in the press, I'm going to situate it a little bit more personally in my own history and my personal perspective on where we are right now. And sort of the history starts with the web. And I don't know, I imagine a lot of you are younger than I am, but some of you may remember the first time that you saw the web. Others of you may have been born with just the notion that the web exists. So I remember being in this basement dungeon of a computer science lab at my undergraduate institution. This guy calls me over and he's like, Jamie, come check this out. And he shows me my very first web page through the Lynx browser. And if you've ever used the Lynx browser, it's a bit of a challenge. It's entirely text-based and you have to tab around between different links. And honestly, I thought it was really dumb. Fortunately, I didn't think the guy was dumb. I ended up marrying him. These are our 4 kids that you can see. But the web, I didn't understand the value. And the thing that really changed my mind about that was web search. And web search is the first scale AI application that people have really used. And I got so excited about web search that I went and worked for an early search engine called InfoSeek, and then went to graduate school to build search engines and think about what that was. In parallel, these 4 kids that show up on the screen were born. They're very close in age. You might notice in this picture, I think they range roughly between like 2 and 6. So my oldest in the middle is Griffin, and my youngest Briar is on the right-hand side in the pink bow tie. They were born between 2004 and 2008, and there were these really significant technological shifts that happened in that period that really impacted our ability to do large-scale AI the way that we're doing it right now. So probably one big shift is the iPhone came out. Like, we didn't, as much as we're all, I have my phone right here. Like, we're all connected to our phones all the time. It's before my kids were born, there were no mobile phones. They existed. We all had feature phones by that point, but we didn't have sort of the rich access to data. During that time also, perhaps less consumer facing, but just as important, you saw the advent of things like Azure and AWS and the cloud. And it was sort of this combination of really significant cloud compute and mobile access to the cloud from anywhere was really important. Another big shift that happened while the kids were, between my first and last child being born was things like Facebook. Facebook didn't exist before Griffin was born. It existed. It was sort of a closed thing being developed at Harvard versus, so there was no Facebook, there was no Twitter. And this notion that people around the world can contribute small little bits of content and aggregate that into something larger was really important. Another thing that came about at that time that again is maybe less on the surface important, but does shape this current moment is Mechanical Turk. And that sort of makes sense as you have things like AWS, and the ability to access the cloud from anywhere. You then start thinking about okay, how can you start doing little small bits of work and compile them into something larger? And these shifts had really significant impact. They allowed us to capture and reason over more data and richer data. And so not surprisingly, during that same period, you also see a real significant spurt in deep learning. You see the first paper on ImageNet, for example, published, and that takes all of this data and it takes Mechanical Turk and it creates large-scale labeled data that we can use for learning. And none of these technologies existed before Griffin, and they all existed before Breyer came into existence. And sort of this combination of having a lot of little kids and these technological shifts really changed the way that I think about productivity. So I don't know if any of you have kids, but it's a lot of work to have kids, and it's a lot of work to have four little babies. I had 4 under the age of 4 for a period of time. There's no time to do anything. Actually, babies are kind of boring. They just sit around and sleep a lot of the time, but you have to be on call and you have to be ready to respond to them at any point. And so I spent a lot of time, because I couldn't figure out how to sort of make use of those little interstitial periods between when a kid needed me. I spent a lot of time playing on my phone. I got very good at Angry Birds. I started trying to think about how to use that time productively, actually learning from what was happening in Mechanical Turk, and got really interested in this notion of micro-productivity and how to take these small little bits of time and help them add up to something bigger, and fundamentally the thinking behind micro-productivity is the thinking behind what work looks like in an AI and cloud world where you're working in a distributed manner, sharing tasks over time. So that was very exciting. I came to Microsoft to work at Microsoft Research, and I spent over a decade in Microsoft Research, really leaning into thinking about AI and productivity and getting excited about that. And then I went to go work with our CEO, Satya Nadella, as his technical advisor, and really think about how to take this research we were doing and bring it to the world, bring it at scale to have impact directly through the products that we were shipping. Spent some time with Satya in that role. And then he asked me to take on my current role, which is as chief scientist, where my job is to think about how to drive research-backed innovation in our core products. I was essentially, responsible for thinking about how is Windows going to look different? How is Office going to look different? How is Teams, how are all these things going to look different in the future? They're well-established products that people have good expectations about. And that was a big, hard task to undertake, in particular because people have expectations about these products. And I was in that role, I was pretty new in role when something really important happened, which is the pandemic and the rapid shift to remote work around the world. It was a really interesting time to be in a new role, in a new place, trying to figure out how technology was going to change how people get things done. Ironically, COVID made my job easier. It was scary when it first hit, and I was like, oh no, are we even going to have space for my role? One of the ways that companies deal with really significant disruption is to drive efficiencies. They get really good at what they're doing. And so there's sort of less space for, doing things that the company's not really good at. However, there's actually two ways that companies tend to deal with significant disruptions. And that second one is to lean into innovation. And it turns out that was especially Microsoft being sort of in the middle of having to help people around the world shift from remote working in office to working remotely, really leaned into that innovation. So there was this, so I've been talking a little bit about this shift with the move to the cloud and edge devices, and and then COVID really accelerating that. It basically created a phase change, and it took all of this primordial goo that was essentially ripe for innovation, and it provided the spark that sort of allowed us to start looking at work practices with fresh eyes, and it created new surfaces where people are working. All of a sudden, we're having all these meetings. It wasn't so common to be doing remote presentations prior to the pandemic or having remote meetings. And so it's new surfaces and new kinds of data, conversational data, to transcripts, all of that, that are important. And essentially that, coupled with the shift to the cloud, has allowed us to get to our current moment where we are right now. And I know folks have talked a lot about the innovation that's been happening to get us here. But I think it's important, as fast as it feels like this transition is that we're in the middle of right now, it's part of a long history, and it's part of where we are. I have a book that I really like. I actually think I probably have it right here. Yep. I don't know if anybody's read the Hagakure. It's quite interesting. It's basically a book that captures a lot of the learnings from the samurai in feudal Japan. And there's a quote that I really like from the Hagakure that says, "In the words of the ancients, one should make his decisions within the space of 7 breaths." And that doesn't mean that people should be making rash decisions. It's very much about the preparation, and that you spend your whole life preparing such that when you are faced with a decision that needs to get made quickly, you're ready to do that. And it's there. And I think that's why that historical context is so important. It places us into all of the preparation that the computing research community has done, and the technology community in the world has done, to get to this place where we can have really significant innovations in large language models, and figure out how to use them and accelerate them. And so I remember back, at the end of almost exactly a year ago, actually, meeting with Sam Altman, who's the CEO of OpenAI, and Kevin Scott, who's the Chief Technology Officer at Microsoft, and some others, to kind of start playing around and get our first look at GPT-4. And I went into that meeting knowing it was my responsibility to take this model and figure out how to bring it in at scale into our products. And actually, it felt like a little bit of that was a scary charter, because we've been trying to, there have been many efforts to bring AI into our products. And as any AI researcher will tell you, who's been studying this stuff for decades, there's a lot of expectation from AI, and it's hard to live up to that expectation. So I went into this meeting deeply skeptical, sort of sitting with my arms crossed and being like, okay, let's see what's going on. And it was amazing to sit and play with the model and see the emergent properties that were really there, and the way that that iteration really worked well, and that ability to sort of have a back and forth, and correct things and work with the model to come up with new ideas, and see things in new ways. And on my way home from that meeting, actually, I lived pretty close to campus. It was a pretty short drive, but I couldn't even get home. I had to pull over my car and actually just scream, because it was just so exciting. And there was, I felt such a responsibility to get this technology into people's hands, and to do it in the right way, and make sure, I sort of mentioned earlier the importance of that we are shaping this current moment. And like, I really felt that in my core, you know, and Microsoft's a big company, but we started moving so fast, and within months we were you know, having this product show up, and having this new technology show up in our products, really at an unprecedented rate. So hopefully you all have played around a little, for example, with Bing Chat. M365 Copilot was announced in March. Currently it's available to a handful of enterprise users, but you'll get to play with it sometime soon, get to see what it's like to have large language models in Word and Outlook and PowerPoint and Teams and all of those places. Really amazing in Teams, for example. To be able to ask real-time questions of a meeting you're in, like what cool new topics should we talk about? What's the next thing we should be doing? And so, you know, we've got it showing up in the practice, and we've sort of got the kind of obvious things starting to show up. But like, one of the things that's so fun about this hackathon, for example, is there's going to be long-term disruption, and that long-term impact really matters. And so what I want to do right now is just really quickly highlight some of the learnings we've had from bringing large language models at scale into productivity contexts, and then some insight of what I think that long-term impact might look like. Probably the biggest learning is that for foundation models to have an impact on work, it really requires a broad ecosystem. You know, we call them foundation models. These models are important, but it's that ability to integrate them into people's existing workflows and into work practices in a way that makes sense, and that takes advantage of all of the information and knowledge that people have that really matters. And so there's sort of four key tenets to what we consider enterprise grade AI. The first is that it operates at a global scale. You know, we have to be bringing this technology to people around the world, to billions of people around the world in every country, in every location, and in an efficient manner with low latency that respects the laws and regulations of every different country, you know, and that's really a lot of work. Also needs to be grounded in your data, and that means not just external data, but like fundamentally grounded in like your emails and what you know and what matters to you. And because that data is so important and valuable, it needs to do so in a manner that's trustworthy, that's responsible, that takes into account you know, that your data is private, that you know, takes into account the influence these models will have. And then finally, they have to be embedded in existing workflows. So I'm just going to really quickly go through these four and show sort of just to you know, a little bit of like titillating detail on some of the research happening here. But it's an area where there's going to be a lot of innovation, and this innovation is fundamental to making large language models truly have an impact. So when we think about the global scale, for example, one of the things that's really interesting about the current generation of generative AI is how good they are across different languages. So typically at Microsoft, actually, when we have like a really new emerging technology, particularly in AI, we actually end up having to ship it in like to an we call it ENUS, English and United States audience first, because that's often where we have a lot of data and have done that training. Interesting about this round of the M365 Copilot work, the Bing Chat work, is that we're actually shipping them to non-English locations from the get-go, because they're able to handle different languages. And there's a number of different approaches that are getting used to explore to make it even better, because it tends to be quite good. But we want to make it even better. So you can try, for example, particularly for low resource languages where where the model hasn't fundamentally been trained on a lot of it, you can translate the prompt into English and then run it and then translate it back. And that works well for low resource languages, but for high resource languages, you actually don't have to do that. And so there's a ton of research happening here. You can see, for example, these are just some examples of some findings about the importance of data. And how more data really matters. So the languages where we do best are still languages where we have a lot of data and the model has been trained on that. Also doesn't do as well on non-Latin scripts. I think that's a really interesting area for research and to start to explore. Another interesting thing about this too, of course, is Translation is not just about translating the language. It's not just about successfully being able to say something, but the cultural context matters a lot. And these language models are starting to exhibit some signs of capturing that cultural context, but that's another area where we need to be doing a lot of research and a lot of innovation. Another thing, obviously, about bringing these models at a global scale is that efficiency matters a lot. You know, there's limitations to compute and memory and bandwidth, and all of these have been true, you know, just in general with the cloud. And, you know, offering cloud services, you have to worry about these things. But, you know, language models represent a real paradigm shift in the workload characteristics and requirements. You know, language models are big. They, you know, we have to, they're serving new scenarios, and we have to serve billions of users with really low latency. We need to be reliable and up all of the time. And, you know, these are hard. And if you've been following the news at all, or like working on building, you know, AI yourself, you certainly know, for example, that there is a real capacity crunch and just having enough GPUs to be able to do this. So figuring out how to allocate GPUs to different workloads is a really interesting problem. At Microsoft, we've done a ton of work around AI ops for cloud efficiency, where you will, for example, like profile a workload and then use that profile as a constraint in the optimization process to try to get really efficient. Something that I know when you sort of start thinking about this, one of the things that you then think about as well is the impact that this will have on the environment, and sustainability matters a lot, and to us and to all of us. You know, Microsoft has a pledge to be carbon negative by 2030, and we want to do this even as we're bringing these models at a global scale to the whole world. Fortunately, efficiency and sustainability are actually aligned goals. So, you know, our work to make stuff more efficient is very well aligned with our work to make things more sustainable. The picture here is an example, for example, some underwater data center work that we've been doing. Another part of the kind of enterprise grade AI ecosystem is retrieval augmented generation. So you've probably heard some discussion of this. You know, a challenge is that the model, like, it's big and expensive to train the model. And the model, what you sort of get from that is really an ability to start reasoning over data, but the data there gets stale. It's not personal to you because these models are trained on publicly available data. And that ability to surface via the context window information about what you know, information about current events is really important. My background is actually in information retrieval and search. I talked about InfoSeek, and you know, my experience with search really changing the way that I saw the web. And this is true for language models as well. That ability to search and pull in the right information matters a lot. It's particularly interesting in an enterprise context. Actually, enterprise search has already done a lot of thinking around access controls and what it means. So, like, probably one of the big things that we do as a company at Microsoft is think about data and who can access data and how can you search across all the data. You have access to different data from what I have access to, and how can we both search over the same index and get only what's available to us. And so this retrieval augmented generation that takes advantage of all of the infrastructure that has been built on, like, access control, it really enables privacy to be part of and a fundamental part of how the language model then operates. You know, of course, if you're thinking about using private data for training, you need to start considering other approaches. There's a lot of interesting research happening right now around privacy preserving machine learning. Things like differential privacy offer an opportunity here. We're also thinking a lot about metrics. You need metrics to understand the privacy trade-offs that you get compared to the value you get from training, so that you can measure and audit what you're doing in this space. So we've been developing principled and efficient approaches to actually assessing privacy risks in machine learning pipelines. You know, another piece of this sort of trustworthy aspect is also thinking about responsible AI and, like, the impact. You know, privacy and security are sort of part of that, but largely we want to think about the impact that the models that we're going to have will have on what we're doing. And so there's a range of different approaches that we're building, from thinking about from the platform piece to what it means when it starts showing up in our applications. And one of the things is language models have brought different kinds of topics to the fore. So fairness and bias have been really a foundational piece of sort of thinking about responsible AI for a while. I almost consider it like the classic responsible AI problems, is to make sure you've got fair training data sets, that you're not having differential impact on different communities with the kinds of applications that you've built. We're also seeing a rise in concern around things like hallucination and disinformation, a lot of new privacy and security challenges. We're thinking a lot about jailbreaks and how to avoid that, prompt injection attacks. And actually, in the enterprise context, the responsible AI considerations can be different as well. It is different to think about when you are helping an organization work than when you're thinking about an application that's out in the world. You think, even just like a good example is even just thinking about content moderation. In large scale external consumer applications, you want to think a lot about how you help people avoid hitting harmful content. But if you're a police department, taking notes on a violent crime, you don't want to be restricting the ability for AI to be helping support those kinds of conversations in the same way you might want to in another context. And then, of course, all of sort of that sort of system that I was showing for responsible AI is part of a larger system. This whole, everything I've been talking about creates the system that we use to deliver our co-pilots to the world. And that being able to build directly into the applications people are using matters a lot. And like it's where you're going to see like the kind of the rubber hit the road. GitHub Copilot is a great example. Devs are 56% faster when using GitHub Copilot. They report feeling significantly more productive. They accept all these suggestions that they get. Like, it's the fact that the large language models, which are showing up in the context of a code development environment, that enables that to actually impact people. And so we've been doing a lot of work to bring large language models specifically into the products. And in some ways you can think about, like, Microsoft products have decades of knowledge about how people work kind of embedded in them. It's just hard to figure out how to use it. Excel is Turing complete. Like, you can do anything in Excel, but like, I can't do anything in Excel. You probably can't actually do anything in Excel. You have to be an expert. Like, there are people out there who are Excel experts, but most of us aren't. And it's really cool to start thinking about how natural language can unlock all of what's been built in there to help enhance human productivity, in a very natural and easy way. So we have, for example, a domain-specific language, ODSL, which stands for Office Domain-Specific Language, that is what is allowing language models to like dive into the depth of functionality that our products have. So that's a little bit about enterprise-grade AI. But then I want to, and I think solving all of those problems is going to be important, but not just important. They're going to be foundational to getting these applications out to people at scale. But they don't really capture how work is sort of changing. And probably the biggest thing that I see changing, and we're going to learn a lot. So take this as like a hot take in the middle of a big transition. But one of the things that is really interesting is, like, most of our experience with personal computers and the way we deal with information is by dealing with documents. And we've got this really important shift that's happening to conversation being where that knowledge exists. And I'll just throw this out as a bit of a provocation, and then I want to leave a little time for questions so we can chat about this as well. But like, much of any conversation is comprised of something that psycholinguists call grounding. And grounding is a process by which the participants in a conversation, come to a mutual understanding. It's how we figure out and know what we're thinking about. So in an LLM context, you're going to do this with iterations. Yes.
You're joining.
Okay. Yes, so in a language model, this is often, you're iterating and talking. And then what you do after you've had a conversation is you produce grounded content. So that'll be like the document. The conversation is essentially us brainstorming or thinking or coming to something, and then we go produce that. And traditionally, this grounded content is more useful than the grounding content. It's where information lives, like we have a great brainstorming session. The thing that we're going to come back to later is actually captured in the documents or the notes or what we produce out of that, not in the conversation. Large language models are super interesting, that they make conversation in themselves useful, because all of a sudden it can start unlocking that information that's embedded in conversation. And so then it actually becomes about like, how do we help make people have great conversations versus produce great artifacts? How do we help you have the best idea in the conversation with the language model and the conversation with other people? And then what's more is language models, because they can extract this information, they can start surfacing it to you dynamically in the context that you're in. So instead of reading a document, a language model can take that knowledge and give it to you wherever you are. I think maps are kind of a fun analogy for this. You see this with maps. My kids don't even know how to read maps now. And that's because the knowledge that's captured by maps get surfaced to them dynamically, so that they know what turn they need to take when, or where the closest gas station is. And so we're doing a lot of research to try to understand these conversations, and so you can start imagining essentially, what does it mean to have knowledge embedded in the conversation? We can understand and we can help our customers and help people who are using language models understand that and make use of that. This is just a fun little example of, you can actually develop good advice for people about how to prompt a model well by looking at successful conversations that people have had, and then asking the language model to figure out what are the successful patterns. Like, this is a set of automatically extracted successful patterns, and they're brilliant. They're really great. Likewise, you can look at the ones that don't work and extract those conversations. And I think that takes us then to, once conversation comes to the fore, all of this thinking about prompt engineering and what does it mean to set up successful conversations becomes super exciting. So I think we've got some pretty exciting times ahead of us to start figuring out the real long-term impact of work. And I think all the educational work that's been being done here is particularly relevant too, because it's really, that is fundamentally education, is how do you set people up to be successful in their conversations and in their production of knowledge and the way that they interact with the world. And I think that's the job ahead of us. I think this is a time where the world needs to come up with a lot of new stuff. And it's a time, that we have a paradigm for coming up with new stuff, and that is science. So it's incumbent on all of us to approach this coming era of AI by leading like scientists. That means, generating hypotheses and testing them. It means building on the state of the art and not feeling like we have to come up with everything ourselves. It means sharing what we learn, in particular, so others can challenge us and debate and validate what we've learned. And it means considering the long-term externalities and thinking about where we're going. So thank you very much for having me here to share a little bit. And I'm excited for all that you've come up with and what's to come.
Wonderful. Thank you so much. That was wonderful. And now I see people are starting to queue up their questions in the chat. So the first question is, how do we prepare our students today for the work and life tomorrow with AI? And how can AI help us today to teach our students differently?
Yes, such an important question. And not one that I have an answer to, unfortunately, yet. But I will say, I find this leading like a scientist paradigm to be quite useful. If you think about, we are entering a world where the rate of change is only happening faster, and like that ability to understand and operate in the face of a lot of ambiguity is important. and our ability to think about how to do things in new ways. The people who are even thus far being most successful integrating language models into their practices are the folks who are like re-envisioning things, thinking about workflows and work practices that are different. In an educational context, the language models actually can do quite well. And I've talked to folks who are like, I guess I had a language model take my intro CS course, and it's like an A-, like they do really well. So yeah, and that's actually what's coming out of the early productivity research is what many new technologies actually kind of create huge divides. Language models are actually, because of this ability to really provide a baseline quality, are not doing that thus far, which is pretty interesting. But so you have to start thinking, if the baseline is everybody's getting an A- in your course, like the trick is to how do you help people then build on that and do more? Like, this is this phenomenal tool we have. People have to know how to work with this tool to work in an area. So like, I have really enjoyed the courses that I see where people aren't saying don't use a language model or don't, but rather say like, okay, tell me what you get from a language model, and then figure out what's wrong with it, how to get better, how to improve on it. And you can just continue to use the model as a tool to get there. But you're responsible for the content, you're responsible for the learning, but like really taking that as a baseline and then using that as a tool to think critically and grow seems exciting to see. But like, it's hard, and like having to deal with really fast change and figure out the answers to this is not easy. So.
Okay, the next question in the chat. In retrieval augmented generation, what is the optimal or most cost-efficient way to ensure that the right amount of contextual or enterprise data is retrieved for an effective LLM response?
Yeah, I mean, and like I said, my background's information retrieval. I find these questions so much fun. They're great. There is so much that's going to come thinking about how we retrieve information into the model, and particularly because I think we're starting to retrieve, it's different kinds of information. So typically searches over documents or web pages, they might be hyperlinked documents, but they're essentially documents. What does it start meaning to search over conversations? How do you use a person's current context and what's happening in the environment? In many ways, you can start thinking about our devices as becoming sensors to pull in all this information to help the model reason over. There's going to be a lot of work figuring out how to do that. In general, we're quite fast and efficient with a lot of search. So I think it's actually a good efficient way. Context compression becomes an interesting problem. How do you take all this information and do some compression? There are going to be a lot of tech, so like we're using the model to develop the queries, to do source selection and figure out what queries we want. And then you want to start giving, actually, instead of giving the model everything in the context window, you start thinking about how do you let it know what's available so it can ask out for it. So in some ways, you can kind of think about like the world is your long-term memory. You pull some stuff into short-term working memory, and then you want to allow the model to know how to access both that short-term working memory and the longer term. And actually, these domain-specific languages that become really interesting for that.
Great. Thank you so much, Jaime. It really has been an honor to have you here, and especially to hear about the new things on the horizon. And I'm anxious to see these new enterprise products come out with large language models. So thank you again. And
thank you.
You're welcome to answer more questions in the chat. We are going to move into our next phase now, where we'll be hearing from our hackathon teams. So we had 3 hackathons. They were in 3 impact areas, and the judging criteria for the hackathons came from Roni Rosenfeld's keynote talk from earlier in the summer. The recording is made available from the website, so anyone who didn't get to see that can go to see under the website's past events. You can find links to all of the recordings of these talks. But in that, when Roni was sharing his vision for what would be positively impactful generative AI, he had 5 principles: safety, positive societal impact, potential impact on quality of life, technical advance, and creativity. And so we, our judges and also the audience, general audience in their sort of listener's choice voting, use these principles to select winning teams from each of our 3 hackathons, which you'll be hearing from today. The goal here was to explore how these advances in generative AI could have impact in 3 really important areas: education and the future of work, medicine and public health, and finance and economics. So now we'll hear from our winning teams. And the first team that I will call up was from Education and the Future of Work, and that is ChatTA.
All right, let me share the screen. Can you all see it? Okay. So yeah, hello everyone, we're ChatTA. The 5 of us are from 5 different institutions with very diverse background, but we get together in this hackathon trying to build your in-house large language model-based teaching assistant because we see a staggering problem. Among our team members, it takes us about $7,000 to take a course, but we enjoy the TA to student ratio of 1 TA to 10 students. On the MOOC class, like the famous CS50, you can take it on edX for free or for $200. However, the TA to student ratio is a staggering 1 to 400. We have encountered the situations many times, either as a student who cannot find a TA to answer our question in time, or as a TA who are struggling to keep up with helping all the students. This is not a new problem, of course, and people have been trying to working on it, and with AI. Traditional AIs like Jill Watson rely on rule-based systems, which restrict their ability to handle complex queries. Overcoming these limitations, LLM possess the ability to understand and generate human-like text. However, tools like ChatGPT simply cannot be trained on different knowledge bases. For example, if we ask about slide 10 from lecture 3, ChatGPT have no idea what I meant. Solutions such as Comingo seems great, but they don't support a continuous improvement aspect. And enter ChatTA, hopefully we will address all of these challenges. So for our pipeline, first we collect instructional materials from courses to build a database. For this hackathon, we collect 2 courses, one intro course and one higher level CS course. And therefore, when a student asks a question on whatever question answering platform they're using, the question can get embedded as a query in our database. Then we retrieve the most relevant document to augment our prompt, and then we send the prompt augmented query to the model. We're using Llama 2, which is the state-of-the-art best open source model you can host on your own server, so you don't have to risk sending your private student data to OpenAI. And we fine-tune the pre-trained Llama with the question answering data we collected, which will make the model more customized and improve its answer quality. But how do we incorporate a continuous improvement? Similar to ChatGPT and many other models, we want to use RLHF, which is reinforcement learning on human feedback. As the semester goes through, if we present the model answer to TA, they can accept, reject, or edit it. Or we can also collect student preference data, and we can use this feedback to continuously improve our model. And finally, if the instructor doesn't feel comfortable directly exposing your student to the AI-generated answer, we can have a guardrail to always ask the TA to approve the answer before it gets to the actual student. So our model will be drafting a response for the TAs to help them save time and answer students' questions more promptly. So for this hackathon, we've built a Chrome extension. As you can see, we can go on to any question answering platform that your institution or online course use. We select a question and ask our model to generate a response. Of course, this is only a mock interface, and people will need to log into our Chrome extension as either a student or a TA in the future, and they get to see different things, provide different feedback to us. So how's our model's performance? There are more details in the report, so feel free to scan the QR code. Here, I would like to highlight the potential of our model to outperform the baseline in producing more factually correct answer and more useful answer to boost TA's productivity. And Emily is going to talk about how we achieve it.
Thanks, Christina. So we found that answers to student queries are commonly found in different sources, ranging from course reference textbooks, lecture slides, lecture videos, assignment PDFs, and so on. As a result, we use these knowledge sources itself to create a vector DB. We noticed three main advantages of hooking our LLM to a vector DB. Firstly, we were able to add new information and update existing information without the costly fine-tuning step. Second, we were able to cite sources for the agent's response. This should help the user to detect model hallucinations to some extent. Third, our model is able to tap into external documents which were not present in the initial pre-training corpus, which is something which Naive ChatGPT cannot do right now. Next. So I just wanted to present some qualitative examples of our model's performance. So for example, for a simple conceptual question such as what is L2 divergence, the actual answer by the TA on Piazza was please refer to the lectures. Now, both our model and off-the-shelf Llama 2 are able to answer the question more or less correctly. But what you would notice is that our model is also able to cite the corresponding lecture videos from where it actually used context to generate the said answer. Next slide, please. So here is another query which asks about the submission format for part 2 of homework 3 for some course. And now it is highly unlikely that the document where the answer to this query is actually present was present in the initial training corpus of the LLM. As a result, the baseline model is unable to answer this query. However, information retrieval allows our model to tap into the assignment PDF to answer the query accurately while also citing the source for its generation. Next slide. Also, yeah, given a logistical query like tell me about the office hours on Monday, the baseline model simply hallucinates while our model provides an accurate answer. What's even better is that once you update the office hours schedule document in our knowledge base, for example, let's say that you remove all the office hours which are present in the document on Monday, our model is able to adapt to this change in information. And if the model is queried again, the answer which it provides reflects the said change where the model says that, okay, I cannot see any office hours on Monday. Now, we've learned so much during this brief hackathon time, and there is much more to learn and do. And I will let my colleague Jan to expand on it further.
So we see that information retrieval is great. It promotes factual accuracy. We want our generated answers to be factually correct. But is it enough for this task that we have at hand? Will it miss it? Will it miss the task? Hopefully, ChatTA is not only as accurate as Google search would be on our personal data, but it's also a great tutor. Can it be pedagogical? Since we have control over Llama 2 and people who make API calls to GPT-4 don't, can we take advantage of this and make Llama 2 a master of pedagogy? So on the next slide, I'm going to start talking about the technical ideas that get us there. So first idea, something that you've heard of, supervised fine-tuning, SFT. So we built a data set from a mix of curated real data, such as Piazza data, and synthetic data, which both contain very clear examples of students' questions and quality answers from TAs. So these examples are practice tests for our Llama model. Our LLM attempts to generate an answer and then compares its generation to the real answer. We call this teacher forcing. It will lead the model to progressively get closer and closer to mimicking the expert data that we want it to emulate. Certain research communities call this behavior cloning. It will clone the behavior of good pedagogical instructors. And on the next slide, I'm presenting what actually the community that calls this behavior cloning is the reinforcement learning community. And the RL community is one of the major reasons that GPT-4 is what it is today. At its base, RL is like training a dog. You give treats when your model shows good behavior, and you don't when it doesn't. It's different from behavior cloning because it's not looking at correct examples. It only makes attempts and gets told whether it succeeded or failed. It's forced to have some sort of deeper understanding of what the task is as opposed to copying. The challenge, though, is how do you create this entity which gives you the treat or not? One relatively simple heuristic, and this is partly what GPT-4 is built on, is using preferences data, which is what we introduced earlier, Christina introduced. So another ML model, different from the generator, is trained to understand when to reject or accept an answer from looking at when TAs and students accept or reject these answers. This is called reward modeling. On the next slide, I'm showing that this reward model is then used to train our dog, our Llama 2 model through RL fine-tuning. But there's a variety of very valuable ideas in the RL community which aim at building these treat suppliers we call reward models in many different ways. Can we extract underlying rewards from expert generation, understanding what's in the mind of the experts when they do their generation? Can we build a set of rules that we define to know what the rewards should be? For those interested, John Schulman, one of the main brains behind GPT-4, extremely important figure in the RL community, gave a talk at ICML 3 weeks ago on precisely these questions. And we're very excited to make this one of the main focus of our work, understanding what should be the reward for good pedagogy. And so on the next slide, we're just presenting many other research questions that we want to explore to make ChatTA the best TA assistant possible. Here's a non-exhaustive list on the left. And on the right, you see snippets of lessons that we thought was useful to share that we've learned so far, such as the limitations due to quality of the data available, the constraints of owning your own infrastructure. When you make calls to GPT-4, it's easy. When you have your own infrastructure, it requires more overhead. The heavy computing requirements of fine-tuning your model, or the fact that generating coding answers is tricky currently with Llama 2. These are observations. And we think that we hope this presentation was both informative and entertaining, and we're happy to take questions.
Thank you so much. We are going to have to move on to the next team, but you can feel free to answer questions in the chat. And so our next team from the Medicine and Public Health Hackathon is Health Advisor.
Thank you, Carolyn. Can you see my screen?
Yes.
Awesome. So my name is Anshul Madan. I will be presenting the Health Advisor project along with my colleague Sonesh. We are an interdisciplinary team. So Health Advisor is a personalized AI well-being advisor providing advice for the general population for behavioral change with a focus on mental health insights. Mental health is one of the biggest public health concerns in the world today, with conditions like depression, anxiety, stress-related disorders becoming prevalent. 50% of postgraduate students have shown signs of depression at some point. Most people would know someone who has suffered from severe mental health issues, especially during the COVID pandemic, even more. Personalized healthcare advice is costly and requires access to human experts. So our solution is to provide move the slide. Our solution is to provide personalized and actionable plans based on individual context, augmented through knowledge of physiological states, behavioral, personal profile, and health goals, enabled through devices like wearable devices, Apple Watch, Fitbit. People rely heavily on context to enrich meaning beyond what is literally said, enabling concise but effective communication. So during the opening keynote of the GenAI Incubator series, there was a discussion between Tom Mitchell and Carolyn Rose, where it was mentioned that text-only large language models are not multimodal. They usually struggle with complete context and an understanding of common sense knowledge. So to make GenAI more and more relevant, building on that context would be important. And we are taking a step in that direction for our targeted use cases. So we collect personal data about the user's demographic information, medical history, their health goals to augment the context and provide actionable recommendations to improve their mental health and achieve their wellness goals. Our hypothesis being that GenAI-based personalized plans can outperform human-generated one-size-fits-all best practice solutions. So now I'm gonna share a demo.
To this app, we aim to onboard the user to collect personal data and the user's health goals to augment the context. Click Submit. Now profile is saved. We will continuously assess mental state like stress using physiological conditions like heart rate and generate proactive notifications with the intervention. Then the user can like, dislike, or initiate a follow-up conversation for the intervention. And then from here on, the user can have a chat and get to an actionable plan.
Right. So Sonesh, actually, no, hold on. So how do we do it? We onboard a user and start building a profile. The stress detection triggers request for an intervention. In the future, we would need we would actually build a model, for example, a regression model based on heart rate derived metrics and other metrics. We also track profile history of user, a physiological state, stress history over time. We de-anonymize the data before using it in our model. And we provide a user agreement where the user provides permission so that we could collect the data for security and privacy. We did a systematic review and meta-analysis to select effective domain-specific intervention types which are mechanisms to achieve behavioral change. With this augmented context, we generate prompts to the GPT 3.5 model, and we do a quality safety analysis to determine when it is safe to generate an intervention before we generate a proactive notification to the user. And on top of that, we support a chat console for follow-up conversations after the initial intervention, enabling the user to get to an actionable plan. Okay, so Sonish will be presenting the next slide.
Thanks, Anshu. So our manual evaluation showed that the system provides more personalized intervention compared to other one-size-fits-all intervention. The system has an enhanced safety system, which we call as a QA agent, which is based on a model which is different from our intervention generation model. So this is based on a FLAN-T5 model, which was fine-tuned on top of offensive dialogue classification data set. And we proved that this improved the results and avoided the poor intervention or offensive conversation suggestions. The whole system was, the intervention and chat system was based on GPT 3.5, but we experimented with other models as well. Next slide, please. I'd like to walk you through a few user scenarios. For user one who was really stressed, our model popped up an intervention of better sleep. And you can see in the system, also gave out a reasoning for that, which is increased workload and technology-related stress based on the user data. You can also see in the second screenshot that the user initiates a follow-up conversation based on the interventions on how to manage the sleep cycle. Again, you can see the system generated more personalized conversation based on the user data. Next slide. Similarly, for the user two, you can see the system suggested healthy nutrition and improved concentration, and adding brain-boosting foods into the diet. The user had no clue of what brain-boosting foods are, and the model actually suggested what and how to include these in the diet. Next slide. So coming on to one of the most important component of our system, the QA agent. So whenever the system generates a conversation or it generates an intervention, it has to pass through a QA quality analysis check. And until it doesn't pass the test, it won't reach the user. Let's see some of the examples. So without QA agents, the Gen AI actually generated the following conversation. So you are indicated that you are single and maybe that's why you are feeling down. Please consider getting married, which actually doesn't make sense. So our model classified this conversation into the label, it needs caution. So the system again stands as a security between the intervention generation and the user. Over to you, Anshu.
Thank you, Sonish. So in our future plans, we plan to enrich the knowledge base with external data sources, WebMD, Reddit Ask Doctor, Stack Overflow Ask Doctor. Our preliminary results did not show much of a difference, but we're going to explore that further. We're also going to fine-tune models based on research papers on PubMed, WebMD. We are going to evaluate the effectiveness via surveys and get real user data collection and feedback. Get more qualitative feedback on the app, especially in areas that need oversight, redirect to humans for severe cases, managing excessive screen time, vetting information to avoid medical misinformation. And there are several potential ways to augment the context further, like electronic health records or visual information, which we want to explore. And we also want to expand to general health beyond just mental health, other classes of interventions like nutrition, physical activity, sleep, habit forming interventions. And we also want to explore a combination of AI and human solutions in the future. So that's pretty much it. Thank you. And I also like to thank Carolyn and Alex for the opportunity to participate and present.
Great. And we have time for a couple of questions. Would anybody like to ask a question? You can put it in the chat or you can raise your hand to speak. Okay, if there are no questions, then we will move on to the next group.
Awesome.
Okay. Our final.
There are some now.
Oh, sorry. Are there questions? Okay, we have time for a couple of questions. So, how do you distinguish between values and safety in this context?
Between values and safety. Okay. If by values you mean the values of the user, so we collect data about their goals, their values during the user onboarding process. And for safety, as Sonish had described, we have a separate quality assurance agent, which trained based on a public available data set, which has examples of unsafe conversations, and we use that as a filter before we provide the final response.
Here's a good one. How would you handle the tension between good health advice and something that might be difficult for a patient to hear or that they might not comply with?
Great question. So one thing I mentioned in the future plans is creative human and AI solutions. So in cases like this, which might be difficult for the patient to hear, we might not want to provide the intervention ourselves, but redirect it to a human professional. So that's one way we will explore how to explain to the patient difficult conversations, difficult to hear interventions.
Okay, there are some more questions in the chat, and I will let you go ahead and answer those in the chat. Aichan, would you like to put up your slides? So our final hackathon winner is from the Finance and Economics Hackathon, and this is Sustainable Investor AI.
Anshul, can you share the slide? Sorry, I'm having internet connection problems, but I will present. Anshul will share.
Sure. I'm just looking for the link. Hold on. Can you see my screen?
Yes.
Yes, go right ahead, Aichan.
I'm starting. Hello, everyone. My name is Aijan, and I will be presenting our Sustainable Investor AI project along with my colleague Anshul. Our interdisciplinary team also includes Akash and Mengdi. Next slide. Our app is an AI advisor for investors with a focus on ESG, which stands for environmental, social, and governance concerns. We provide the investors the ability to judge a company's performance by combining traditional financial metrics, such as revenue growth and profitability, with sustainability metrics, such as carbon footprint, social impact, for a more comprehensive understanding. ESG is increasingly becoming an important investment decision criteria. Investors recognize the impact of environmental and social risks on companies' financial performance. However, they complain that they cannot effectively incorporate ESG in their investment decisions because of issues such as data quality, greenwashing, which is the use of misleading labels or advertising to create an illusion of environmental responsibility, and consistent and reliable reporting. Investors also indicate that reading through a large number of complex sustainability reports to extract the needed information is time-consuming and labor-intensive. Next slide, please. Our solution is to build an investor advisor that effectively incorporates ESG concerns to help users make informed investment decisions by providing reliable ESG information in an interactive interface, along with indicators of how trustworthy the provided information is. Our end goal is to leverage generative AI to summarize and analyze financial reports, such as 10Ks and 10Qs, as well as sustainability reports. For the hackathon, our focus was on the analysis of sustainability reports and to figure out how to warn our users to the degree of greenwashing in these reports with our predefined questions. We will now share a demo of our app.
Analyst selects an industry sector, click Submit, can list companies from the selected sector, and then summarize the selected company. Click Investigate. The summary is displayed along with the trustability score. User can select the question to analyze on. Use question. Results are returned. All responses would generate the trustworthiness of the data sources and links to the data sources. And the user can also see the excerpts to understand the source of the answers and thereby make an informed decision.
Okay. Now how we do it. So the analyst can summarize and analyze companies from a selected sector, which will result in a generation of corresponding prompts for our Claude 2 LLM. In addition, our backend system will augment the context with the corresponding sustainability reports and company metadata, generate prompts to measure the trustability of data sources through the Claude 2 LLM. This technique is commonly referred to as retrieval augmented generation. We handle safety in our prompts. All responses from GenAI return trustworthiness of data sources, deep links to the reports, along with source excerpts used for the answer. In the future, some things that we plan to do are historical trend analysis of reports to determine red flags, automatic collection of reports from agencies like corporateregister.com, evaluating with use of external data sources with standards information. Now I will pass it back to my teammate Aijan for the next slide.
Anshul, I can actually share now. Can you? Yeah.
Okay.
Sorry about this. It was an unexpected data problem. We use newly drafted ESG standards to create our prompts. To get more accurate results, what we do is we have tried different prompt tuning techniques. First, we taught Claude to act as a senior equity analyst with expertise in sustainability for role-based prompting. Second, to prevent hallucinations, we asked Claude to print out the excerpts from the reports that it used to create the answers to our questions. We also implemented asking focused questions one at a time, including metadata on the company and giving Claude clear and specific instructions and scoring criteria. Did it work? On the left are our results without prompt tuning, when we asked all of our questions at the same time without any further guidelines. Claude gave us very shallow answers. On the right is when we applied all the fine-tuning techniques, asking separate questions with separate prompts. We see that the answers are more accurate and are in line with what a domain expert would have given. In the Q&A, we can talk more about the results of our further experiments we ran with our model. So overall, because our reports were long, around 100 pages, we chose Claude 2 over GPT for its memory and recency advantages. For reliability, we realized the importance of clear and specific prompt guidelines, as well as asking Claude to trace the path to answers. Also figured that our domain-specific knowledge helped us greatly in prompt engineering. Now back to you, Anshul.
Hey, Aijan, I think there are some comments. Well, actually, I did see the slide. So I see some comments saying that we couldn't see the slide, but I was able to see your slides. So not sure about that. Could you move to the future plans? Thank you. So in our future plans, we plan to involve domain experts like financial analysts or sustainability experts in the prompt development loop, analyze financial reports, expand the scope, expand to industry-specific guidelines, provide unbiased and transparent solutions for regulators to monitor compliance, weak spots, omissions, greenwashing practices, alleviating reliance on rating agencies. Supplemental analysis by incorporating independent sources of information, third-party assessments, public opinion surveys, expert evaluations to mitigate bias against the firm's perspective, and judging score change over the years to understand red flags. That's it. Thank you.
Great, and we have a few minutes for questions. I'll ask a question. What do you anticipate, so when people want to invest and they are asking questions about investment, obviously it's really important to have very up-to-date information. You have shown how important it is to do fine-tuning, but of course that is work to set up. So how do you keep this current?
Yeah, great point. LLM models are trained at a certain point of time, like GPT has been trained till, I think, September 2021, right? So it is important to keep it current. So definitely building a good retrieval system, it will be important. So a robust retrieval system and feeding in the right data, public data sets would be very important. So as part of our fine-tuning efforts in the future, figuring out the right data sets to use and building a robust retrieval system that would input the relevant context based on the type of query would also be important.
Great. And thank you to all of our hackathon teams. This was great. And I see there's another question in the chat, but we are transitioning now to our second keynote by Mona Diab. So I will go ahead and put up a transition slide here. Thank you, teams. So Mona Diab, I'm very pleased to say, is our new LTI director. We waited for a long time to have a director to replace our founding director when when he passed away just before COVID. And we're so pleased to have Mona, and she'll be speaking to us today. She has recently transitioned from lead responsible AI scientist at Meta to be the director of the Language Technologies Institute. She's famous for her work on responsible AI and Arabic natural language processing, and is also generally passionate about language, mind, technology, and society, history, politics, and nutrition. And without further ado, I will turn it over to Mona.
Hello, everybody. Thanks for this lovely introduction. And yeah, especially the nutrition part, right? So let me share screen. You can see this now? Okay, great. Yeah, so today I want to talk to you about responsible generative AI with a lens from NLP, but basically how to do things in practice. Most of the images are produced by DALL-E, and as you just see right there, I just recently joined the CMU, so my email there is the CMU email. So this is not a crowd that I need to introduce this to, but there's a generative AI proliferation from all sorts of walks of industry and also academia. But with great power comes great responsibility. There are huge advances with truly disruptive technologies. Just one second, let me just slow this down, sorry. Huge advances with truly disruptive technology changing the NLP and AI landscape. The whole narrative, research, and product landscape is also changing drastically. Oops. It's extremely accessible, fluent, and intuitive, which garners trust almost immediately, as you all know. But there are problems, right? So there's LLMs, which is basically the, the technology that powers generative AI with overconfidence. There are hallucinations, disinformation, fake videos, fake news, and so on. There's bias, but there's also instinctive anthropomorphization. So we're really at an inflection point. So today, generative AI, as I mentioned, is powered by LLM technologies. And this gives you just a sense of how far things are and how big they are. So for example, we have some of the larger language models. This is a little bit old, but basically there are upwards of 540 billion parameters for a language model like PaLM. And you have Llama 2, which just came out from Meta, where I was recently part of. And Llama 2 was around the biggest model. There are 70 billion parameters. But in general, we're talking about huge compute power. And basically, it's state of the union. There are fierce competitive scaling race. So we have ChatGPT, Llama, Bard, Claude. Adoption and convergence rate. It took Netflix, just, I don't know if people know this, but it took them 10 years to reach 100 million users. In ChatGPT, it was almost 2 months for reaching that same number of users. And there's an impact on environment, especially scale of the required compute, and it's cost prohibitive. We know GPT-3 costs around $4.5 million. And I know for a fact that internally, OPT, for example, the 175 billion parameter model cost us almost $5 million. But there's also a stark reflection of the haves and the have-nots, whereas academia in this whole picture, let alone non-Western, non-US Silicon Valley, West Coast voices. So there are some open questions. What, where, and how regulation and guardrails? So how do we ensure the veracity of language models, choice versus opinion data, the provenance and the confidence? Which and whose ethical value system are being propagated in these technologies? Even if identified, where and how can it be incorporated? What about cultural awareness, sensitivity within and across cultures and languages? And there is a small alert here, the web is not really a true reflection of cultural, even linguistic diversity in the world. So, and what about multimodal foundational models? Do they help mitigate or exacerbate some of these problems? There is the grounding and modal translation, for example. So just to give you an idea, this comes a little bit from the perspective of how do we do this from another angle. There's a coarse granularity of society. So you have society and language and then dialect and sociolect as sort of like concentric circles. The interaction between norms and ethical values doesn't really happen. It manifests itself on the societal level, but really it's a reflection of the sociolect of an individual, which means that not necessarily just the dialect or the way they speak, but actually the context in which they live. So there's a need for ethics, but also for that level, we also need anthropology and sociology to inform us on how to interact with these types of problems that we need to incorporate in the models that we try to build or in the technologies that we're trying to propagate. So just to give you a high level brief status of the AI field, but again, from the lens of natural language processing, this is very coarsely simplified. If you think from the 50s on to the year 22, we had an increase in performance. Is there still room for improvement? What tasks, what technology? Are we asking the same or different questions? In terms of compute and data scale, we've gone up also tremendously over the years from the 1950s until today. But efficiency has gone down, accessibility has gone down, transparency has gone down. And if you think of NLP as a proxy for AI, we also see a level of transparency that's gone down. So think about rule-based systems that tend to be more and more transparent. You go to the classical statistical machine learning approaches in NLP, they also seem to be a little bit more opaque. And then now with the deep learning and end-to-end systems, they're very much opaque in terms of their transparency levels. So with what was happening before in the rule-based system world, you had morphology, phonology, syntax, semantics, and pragmatics, and then you moved on to feature engineering and then representation learning. But basically, opaqueness, unpredictability, hallucinations, privacy and violations, privacy violations, harmful output, like things that contain bias, misinformation, disinformation, and inefficiencies are becoming paramount in all of these models. So these are symptoms of uncontrolled systems. So uncontrolled systems tend to be opaque, unpredictable, hallucinate. They tend to have privacy violations. They tend to have harmful output and so on. So this is an indication of a lack of control. Being able to control the outcome and the performance and predict it reliably is what I mean by control here. So essentially, if you think about it from the perspective of how does it compare to other dimensions that we've talked about in terms of performance and compute and data scale, system understanding and control has been going down. And hopefully what we'd like to see as a North Star for the NLP AI's landscape for the technologies is that we want to see, the control going up, the compute and data scale going down, but also performance still going up. So how can we achieve this? So the question becomes, in order to control, we need to infuse guardrails, which come from understanding the underlying phenomena. So a lot of the work that we tend to rely on right now is a lot reliant on what we call learning by osmosis. So this whole paradigm of absolute self-supervised learning has shown its colors. We need some prescriptive knowledge infused, identifying what the appropriate prescriptive knowledge and how much of it is in an area of research, but relies on understanding the phenomena, nuances, and the contexts. And this leads to more explainable and transparent models and systems overall. So, so I think that should be the next future kind of investment. So what's the proposal? Consider NLP AI technology as critical systems like medical devices and airplanes, more guardrails and regulation. But central to critical systems is robust evaluation. Think about red teaming, root cause analysis, and reliable mitigations. So what are phenomena, what does a controlled NLP AI look like? It should be safe, accountable, predictable, transparent, private and secure, reliable and efficient. So this should be the future of AI and NLP by extension, which is really controlled NLP. Also, NLP needs to be usable and has utility. And this is central to the NLP enterprise in general. So therefore, NLP AI should be trusted and sustainable. So controlled NLP, as I mentioned, is safe, accountable, predictable, transparent, private and secure, reliable and efficient. But we've heard these tenets before, right? These are really the crux of what's called responsible AI. So what's responsible AI is about accountability, governance, robustness and reliability, privacy and security, fairness and inclusion, efficiency, transparency, explainability with ethical design. So I'd like to propose a responsible AI framework, and it's my perspective and my proposal, so nobody else should be getting any blame for that. But it's inspired and informed by many published responsible AI manifestos that came out of Meta, MSR, Google, partnerships on AI, etc. So responsible innovation is one dimension, and it addresses the why. Why we produce AI technology addressing societal impact and human development responsibly. So think about ethical design. Responsible systems addresses the what. What AI technology? We cover research, engineering, products, privacy and security, safety, fairness, robustness, reliability, explainability, interpretability. These are some of the assets associated with the responsible systems. Responsible research conduct addresses how we conduct our research. Development and deployment include accountability, reproducibility, efficiency, and openness. And then finally, diversity and inclusion addresses who our target users are, the developers and the researchers. So think about team makeup, safe meetings, accessibility, and so on. And of course, these dimensions overlap. So what does it mean to have a RAVE mindset? If we're to consider AI technologies as critical systems, then we need to produce RAVE compliant technology. So now that we've created this sort of like framework, can we actually make our technologies compliant with this framework? RAVE applies to both AI performed responsibly by us, applied and deployed responsibly for the user, but also needs to be inherent in our defining, devising, development, dissemination stages of the technology proactively. So thinking responsibly, I contend, is not an end stage, it's actually a muscle that strengthens with practice. So what is the current practice? The current practice is many people in our community work on aspects of responsible AI, but mostly disparately. And for the majority, responsible AI considerations are typically an afterthought or optional, only heeded by those who work directly in that space. And actually, which is even worse sometimes, mostly confined to the ethical limitations paper sections, if present at all, in our papers and our publications. So why do we need RAVE for NLP AI? NLP AI technology and artifacts have huge societal impact. So think about responsible systems, responsible research conduct. NLP AI technology is in need of generalizable North Star with more scientific integrity. RAVE ensures human value alignment. This comes responsible innovation. And RAVE emphasizes human centricity through ethical design, therefore ensuring utility and practicality of our technologies from a diversity and inclusion perspective. And RAVE builds trust, entailing higher user adoption. So technological breakthroughs with enormous potential for benefit in society typically face barriers in adoption when lacking public trust and confidence. So this has been noted across all kinds of inventions. So what is the motivation for adopting RAVE for NLP AI? A framework serves as a guide, creating a space and a trajectory for our field, but also a defined framework serves the community as a forcing function. We think proactively about RAVE dimensions, explicitly addressing them in our design. So think about research questions and hypotheses. What is the benefit of a framework? Think about random brush strokes. No matter how skilled the various painters are, it doesn't need to be the Mona Lisa. But if you have a framework that tends to serve as a good coordination factor. So is the Mona Lisa attainable? Let's see if RAVE empowered NLP AI can get us there. So what's the objective again? RAVE from inception to dissemination, RAVE for NLP at scale, which is the challenge. So RAVE for NLP AI artifacts checklist. This is kind of a proposal that I'm making here. Just 1 second, sorry. Responsible innovation, you can ask the question, is the purpose of my work benevolent? Address considerations and limitations that addresses the why. Responsible systems, is my tool model system robust, reliable, safe, generalizable, efficient, sustainable, etc. Addresses the what. Responsible research conduct, do I have full traceability, accountability, compliance, reproducibility, etc. Addresses the how. So possible subgroups as team members, target users, etc. So this is diversity and inclusion, and addresses the sorry. Okay. So a high-level RAVE operationalization. This is inspired by some guidelines that we created internally within Meta, but this is actually what we started employing internally within Meta. So at project inception, we look at intended outcomes. Who will use this research? How do you design your project? Can you consult with others and envision potential pitfalls? This is responsible innovation. During R&D, we look at data collection, the sourcing of the data, the model training, the evaluation that covers RS, responsible systems, responsible research conduct, and D&I, diversity and inclusion. And at dissemination, we look at where do we disseminate our talks and where and how do we do that? How do we engage with the community? Do we do model data, code cards? How about transparency? How about solicitation for feedback? That addresses responsible research conduct as well as diversity and inclusion. There are some questions to ponder. Is RAVE expensive? RAVE is typically considered a friction point in the current prevalent afterthought paradigm. But I would contend that friction is mitigated in the proposed proactive RAVE paradigm that I'm proposing. And there are some considerations. There are potential trade-offs between RAVE reliability level versus cost. Things like time to market, depending on application domain, whether it's medical and legal, How far can you go with RAVE and so on? What does this mean for academia? Does this only factor for industry? So collaboration between software engineering, testing, product managers creates even more friction points. So need for full control to be able to calibrate the level of reliability, hence affecting cost and level of applicability. But there are also ethical considerations that might profit, but having more RAVE voices should internalize the paradigm, and that could tip the balance. And can RAVE inadvertently create tiers among NLP AI practitioners? I say no, not if D&I is taken seriously, considering learning that different skill sets and profiles are needed to paint the Mona Lisa. So the reminder, future NLP is trusted and sustainable NLP AI. Could RAVE for NLP and AI lead us to this future? So this is the rest of my talk on how to do this in practice. And I contend that a responsible NLP AI is achievable through trusted NLP AI, and a responsible NLP AI is also achievable through sustainable NLP AI. And I'll give you some examples of that. So how to attain trust in NLP AI technologies? Trust in the purpose. So ethical considerations, basically think about augmenting human abilities as opposed to substituting them. This is a big debate. And automated assistant decision-making for sensitive domains needs to be reconsidered. And then there are all kinds of issues that people are discussing today, as usual, around copyright, IP, and plagiarism. But also we need to trust the process. So building trustworthy development and evaluation frameworks is critical to trusting in the technology, but also trusting in the outcome. Is the outcome safe, reliable, and robust? Is the outcome where needed explainable? And if we're devising practical accuracies, are they accuracies that reflect user expectations? And do we have full transparency in the dissemination process? So the three aspects are trust in the purpose, trust in the process, trust in the outcome. And these are reflective of the RAVE framework in responsible innovation, responsible systems, and responsible research conduct. So there are many commendable efforts in the community. However, some loopholes that explain loss of control in current popular scaling paradigms. So for example, we have a lack of deep understanding of large models and data for training and evaluation. We have lack of rigor in annotation processes and evaluation data, evaluation, development, and training data. So we need some kind of an action science. So basically this leads to lack of trust in the process. But also we have lack of practical accuracy metrics that are commensurate with human perception. So for example, we claim that our system is at performance X, but really it's at performance X minus 30%. So that in itself is a very bad practice. So how do we mitigate that? Lack of reliability and stability of performance, so that you have unpredictability. So this leads to, and lack of transparency, explainability, interpretability, and openness. So this leads to lack of trust in the outcome. So I'll just give you one example from dealing with trust in the process, which is around large-scale tooling. I believe in automation, and I believe it's critical for trust in the process. So this is just a paper we published last year around tooling for data characterization. And basically, it's a toolkit that is basically a dynamic, lightweight platform and infrastructure that enables easy definition, configuration, calculation of quantitative metrics over large corpora. Think about data at scale. So think about large language model for training data. And this was actually used in our language models internally at Meta. So it comprises 61 metrics. The majority are reimplementation of Cometrics metrics, which came out in 2004. But it gives you a nice dashboard to visualize and understand data with respect to defined metrics and their inner correlations, standardized Jupyter notebooks, discovery correlations between individual characteristics and outcomes, and we fit multivariable regression models to predict model performance based on text characteristics. And the motivation behind this was that basically we recognize that NLP data sets are often treated as homogeneous data sets with single summary metrics to understand model performance. And there are large data sets that are known to contain biases, artifacts, spurious correlations, so summary metrics fail to surface such aspects. And most available tools for analysis are not easy to use or scalable. So researchers rarely include insightful breakdowns in their papers. So the objective was to gain more understanding and control over large data sets, specifically targeting robustness. So can we characterize sets of text on which we expect our model to work significantly better or worse? Can we do better data selection? Can we use text characteristics to select a more representative, diverse set of training examples? So think about selecting a more representative training set to increase downstream performance, or select a better validation set so that the perplexity measure at the language model training time correlates better with downstream task performance. And also think about bias. Are there characteristics related to protected attributes that result in different performance? So TCT in action. The current practice looks like this. You have a model predictions, and you have the model and the data that lead to model predictions, and you just iterate over this once you have some evaluation metrics. What we do is add some characterizations, and we iterate on the data. And then actually, even before that, after that, we in fact correlate the performance with performance in the systems. So this gives us a sense of what the influence of the data sets and their choices have on the performance. So we basically increase the role of data visibility in the pipeline, like our visibility into it. So this is just to give you a sense of what the dashboard looks like. And by the way, these are all publicly available on GitHub. So it shows you a lot of various ways of looking at the data from different perspectives and so on. But also it shows you correlations, it shows you regression analysis and model performance data. And just to show you how much we've actually used this. So we had a language model that's a multilingual language model that was 7.5 billion parameters. And we were very confused around its performance on English. Noted that the performance on these difficult, challenging tasks was much less on the multilingual English section of this multilingual language model compared to, a vanilla English language model, GPT-3 performance. So we asked the question, is downstream performance on English tasks affected by some shift in language distributions in the pre-training data? And lo and behold, we used TCT as an analytical tool, and we're able to find that there is the lexical diversity metric, which is basically, we found that more overlap between GPT-3 training data and test data distributions compared to the English section of the XGLM training data and its test data distributions. So this became a very interesting insight, but we could actually verify it quantitatively. So basically looking at the lexical diversity metric, it gave us some insights and interpretability to scale, to performance at scale. And another thing that we think is very important, but I'm not going to delve too much into the details of that, is around trusted annotation ecosystems. So can we trust our evaluation data? And I believe this is critical for trust in the process. I will move on to the next section around responsible AI via sustainable NLP AI. Sustainability of NLP is critical. So is NLP AI saturated? We need to grow in terms of solutions, systems, users, researchers, and developers. And I believe D&I is a cornerstone of NLP growth. In order to ensure longevity of the field, we need to heed the impact on the environment, so green AI, but also collaboration with other disciplines within CS, linguistics, and across the IL campus makes our discipline stronger and more resilient. So in helping shape policy and regulations allows our voice to be heard and leads to us shaping the future of NLP. So what are some aspects of sustainable NLP? Accessibility. So reaching more people in various languages, lowering the entry user barrier cost to enter the field, but also it needs to be useful, relevant technology, and also has an impact on people's lives. And it needs to be maintainable. So think about how do we grow these communities of researchers and developers, but also needs to be transparent, like in terms of the explainability, interpretability aspect of it, in terms of, and by the way, I just need to highlight that I use these terms in this presentation interchangeably, but they actually have different connotations and different uses, explainable versus interpretable. But essentially transparent dissemination of knowledge through accountability is critical, but also needs to be benevolent for societies avoiding harmful impact, think from the ethical perspective, and for the environment, lowering energy footprint, for example, or cost of use. So if we think about this in terms of the RAFE framework, accessibility and growing community of researchers and developers is a diversity and inclusion tenet and dimension within RAFE. Responsible innovation addresses utility, so think about useful and benevolence. And responsible systems around robustness, transparency, explainability, and efficiency addresses utility, but also transparency and benevolence for the environment. And then responsible research conduct around transparency and accountability and traceability and efficiency is very critical to maintainability and benevolence. So how can we operationalize D&I for a sustainable NLP and AI setup? Why D&I should we, and actually before going there, why should we consider D&I to be a cornerstone of sustainable NLP? Morally, given the utility of AI technology, it's incumbent upon us to ensure accessibility and adoption by all people. basically giving them the freedom to reject it if they choose to. Otherwise, it's a form of disenfranchisement. And I remember using this term and people thinking it's too strong, but I actually really inherently believe that this is critical. Scientifically, DNI serves as a forcing function to think of low resource scenarios, where low resource refers not just to the language presence digitally, but also to the culture, domain, topic, resource availability. And if we adopt this perspective, then even the English language has low resource settings. And opportunistically and strategically growing our communities by using our technology to make the science accessible. So think about taking NLP to local communities, leading to more inclusion and diversification. So how do we do DNI? Here's a bird's eye view. Users need to have more access, increasing the number of users and lowering the accessibility bar. To think about more efficient systems that could fit on smaller and cheaper devices. And believe it or not, majority of world population is not on the internet. The web is not a reflection of world cultures and languages yet. So basically invest in cross-cultural multilingual models, unified foundation models that make them more efficient. Ensure our teams are as diverse as possible to reflect different viewpoints. But I believe this is not even sufficient because, however, as it's capped by team capacity, there's a need to attract homegrown talent to work on NLP AI in local markets to achieve mirroring effect, increasing the global footprint and global balance for NLP and AI technologies. But all these increasing the AI talent pool by demystification of our sciences, especially at high school levels, generating scientific materials in different languages. Basically, side effect of that would be creating and unlocking NLP creativity in a truly global manner. Evangelizing NLP through global media, not sure we still need that. Think about echo chambers. Encouraging conferences and outreach programs in diverse locations. So taking NLP and AI to more parts of the world, think about the global south. So my talking point number 3 is treat DNI as a first-class citizen in enterprises. It is beyond doing good. It is not a nice to have or a luxury. It's for our own good and the longevity of our field in general. So I'd like to just showcase a couple of use cases of DNI in action. So this is the XGLM multilingual language model architecture that we actually proposed back and actually released to the public in 2028, 2022, early 2023. Essentially what it was is like 4 language models of various scales, up to 7.5 billion parameters, similar to GPT-3 on multilingual data. We went the extra length of balancing out the data sets across 30 languages from 16 language families. We did a lot of upsampling from the tailored distribution. And basically the performance was comparable to Anglo-centric models in 0 and few shot settings. So one highlight was basically unsupervised machine translation. If you're interested, you can read the paper. We have several use cases that were very surprising. But we asked the question, does unsupervised pre-training on a diverse set of languages yield competitive translation performance? Lo and behold, yes, XGLM outperformed GPT-3 with few exceptions on high resource languages, especially on larger language model versions. But also XGLM is competitive with SOA for supervised machine translation baselines, even outperforming them with 45 out of 182 FLORAS 101 language pairs. And just for those who don't know, FLORAS is this collection of data sets for translation evaluation that has a majority low resource languages, and some of them are extremely low resource. So this was very, very interesting. What are the benefits of an XGLM and a multilingual language model? So we think about energy and maintenance efficiencies from an engineering perspective. The models that represent single unified models catering to many languages, which have wide application across many applications, but also a unified single model saves on carbon footprint. And a single model, despite having the risk of being a single point of failure, has a powerful incentive to being easier to maintain, access, distribute, and track. And models such as XGLM represent a paradigm shift from the Anglocentricity of the world and being able to cater to lots of languages on equal footing. But also paying attention to the design of such models is critical. So in order to ensure equitability and inclusion, we needed to balance the different language representations. And that was not exactly straightforward. And possessing such powerful multilingual models can perform well, especially for medium to extremely low resource languages, helps alleviate the burden of creating supervised data for such languages, especially for those economically challenged languages. So medium to low resource digital presence, for example, goes hand in hand with economic disparities. And moreover, having such models catering to scarcer languages spurs scientific research in those languages, leading to more diversified NLP. So it creates a synergistic loop and cycle for sustainability and more diversified sciences in the broader sense. The second use case I'd like to highlight is an initiative that I spearheaded with Martha Yifru in 2022. It's called the 60/60 Globalization via Localization Initiative, which is basically a special challenge. So the challenge was for ACL's 60th anniversary. ACL is the major community for natural language processing, a premier one actually. And the idea there was that we wanted to enable multilingual scientific communication in 60 languages across all modalities, text, speech, sign language, etc. So basically the objective was to increase accessibility during and post conferences. And the core theme was globalization via localization. And the duration for this initially started off as a single year, and now it's become 2 years, and it's by the community for the community. So why 60/60? It's around democratization of CL NLP science, but also removing the ingrained language bias in the scientific landscape and providing all a voice to unlock their creativity and innovation without language barriers. So think about empowering scientists to think scientifically in their native tongues and inspiring younger upcoming STEM scientists, creating scientific language and terminology in many more languages, and current advancements in CL technologies, we believe, are mature enough to take care of this at scale. And the question that kept coming up is, are we giving up on English as a universal language of science? And we have an adamant no to that. So how is 60/60 accomplished? The Seed 660 initiative started in effect in March of 2022. We had 6 active work streams around speech translation, text translation, scientific terminology curation, rectification, sign language interpretation, slide presentation translation, and of course the website creation to host all of this. And basically ended up being a global collaboration among academia, big tech, medium tech, nonprofits, and startups. And by the end of the challenge, the aspiration is to have a comprehensive translation for the entire ACL anthology in 60 languages, a comprehensive standardized scientific and CL terminology list with contextual examples in 60 languages, the ability to have live cross-lingual CC closed captioning and dubbing in 60 languages, a comprehensive repo for all talks and videos from the CL community curated and translated, both subtitled and dubbed in 60 languages. And we spurred research into sign language. We actually funded the SPLAT ACL 22 workshop. And we start thinking beyond translation for democratization, thinking about demystification of CL and AI. So the SEED initiative had several sponsors from, as I mentioned, it was a global collaboration. And that was it for that. So I just wanted to end by highlighting why should people like people in this audience care about generative AI, about responsible AI or RAFE. I think this allows for enhanced user trust. So we think about responsible AI practices can help build and maintain user trust, improved ethical targeting and personalization if you are in that business, mitigating reputational risks in whatever technology you're building, and compliance with the regulations. But also, it allows us to be transparent in our data collection practices and be more equitable, but also cater to fair decision making and differentiation and competitive advantage. If you have, responsible AI as a unique component of your technology, that could be an interesting competitive advantage. But there's also long-term sustainability. So responsible AI practices are not just about meeting immediate ethical requirements, but also about creating sustainable business models. And finally, I'd like to end with some recommendations. NLP with DNI as a first-class citizen value, elevating testing and validation to be as critical as development and incorporating that into our practice, and doubling down on transparency and openness. And making responsible AI core to our enterprise front and center. Thank you very much, and thanks for your attention.
Thank you so much, Mona. And we have a couple of minutes for questions. People can type their questions in the chat or raise their hand if they'd like to be called on. I guess one question I'll start off with just to kick it off. In some of our panel discussions across the 3 target areas, all of which are kind of critical areas where mistakes could be harmful to people, there was this tension between wanting to be careful and recognizing that the technology is not quite there. And as we think about all these principles for RAI, I think we would agree that we still need to work on these things and we're not quite there. This is in some ways a research agenda because we need to figure out how to actually do this. So people were saying, well, should we wait then? Is it technology not really ready for application in that case? Should we be conservative in the deployment? Or is there a worry that there are opportunity costs, that if we don't take advantage of the improvements that we're actually doing harm? So where do you fall on this spectrum? And how would you apply your principles to a decision like that?
Yeah, so it's always going to be a trade-off, right? So I think I have this in one of my slides around, is it expensive? And it's exactly this point of like time to market. This is the lingo from industry. Is like, when do you actually figure out the right spot? And we did this with OPT. I'm just going to give an example of OPT 175 billion. We knew it had all kinds of issues with it in terms of safety from the perspective of, we did as much as possible testing and vetting, but it still had some loopholes that led to, some harmful behavior. But the openness and that's why it was called OPT, because it was open. We actually released everything, like the data sets, the parameters, the weights, the weights, and also even our logs, like how we trained it and what have you. So we basically decided to put it out there for people to test with the several caveats. So for example, not to be used for commercial use. Not to be used by, so making people acknowledge this. So I'm not concerned about development. My concern is always about deployment. So deployment to the world needs to come with extremely, transparent guidelines and extremely transparent, caveats. So, and we make it front and center, like, you use it at your own risk, knowing exactly what's entailed in this. But of course, you're always going to have nefarious people using this to their disadvantage, to disadvantage other people. But I guess that's the case with all kinds of technology. So I think we don't have to wait until everything is done exactly right. But that's why I'm a big proponent of testing and doing our due diligence, so to speak. So so this is something that and the problem that we have with testing and evaluation is that we don't have an evaluation science per se. And for example, this notion of red teaming is done in a very ad hoc-ish manner. And this is part of the reason I'm moving back to academia, is that I'm very interested in seeing these things develop into disciplines where we actually have principles around how to do this at scale and how to do this in a very methodical way, as opposed to the way we sort of improvise right now.
So I'm still waiting for people to either raise their hand or type a question into the chat. So in the meantime, I'll ask another question, and that is, so I wonder what transparency really means for people who are non-technical coming to the technology with their very understandable kind of unrealistic expectations, and especially connected to the idea of anthropomorphization that you mentioned before, which of course, from a marketing perspective, is something that's valuable to leverage and yet could be harmful. So what are the different ways that we need to actually define that transparency? And is it all on the side of how the technology is developed, marketed, and provided, or are there other aspects of how our society absorbs and learns to interact with technology that are also part of the equation?
I completely agree. I mean, you sort of answered the question yourself. It's really like increasing societal awareness of the shortcomings. But I mean, I'm also not on the side of like doomsayers, right? Where you're like, oh my God, you should not touch this technology. And believe it or not, I'm currently in Tunisia. And the president of Tunisia gave a talk yesterday around, it was the Day of Science, or the Science Day. And in his speech, he basically spoke about AI. And he said, it's a dangerous technology, we should not touch it, period, verbatim. And I was just shocked by that. So you have this type of messaging of like, you know what, you should not be even coming close to AI or technology. And that's counterproductive, right? We don't want to have that kind of messaging. but we want to be increasing people's awareness about the shortcomings of the technology, what it can and cannot do. And that assessment in and of itself is actually not necessarily trivial. So you want to be basically, it's all part of this whole ecosystem of having the right kind of testing, the right kind of evaluation, the right kind of jailbreaking, but also having the right kind of expectations and making them, so for example, one of the problems that I've seen around technologies is when they're being transparent and they claim they're being transparent and they're being informative, they inundate people with a lot of technical jargon, which is not necessarily conducive to their understanding of what this technology is capable of or lack thereof. So how can we, the version could understand and the jargon that people could understand, or not the jargon, I guess the language that people could understand, and make it also situated in real case scenarios. So tell them, for example, this cannot be used this way because it could end up leading to this or that or the other. So awareness, increasing awareness in a nutshell is critical. But then it's incumbent upon people who are developing the technology to be able to themselves trace what they've been using in the technology. So unfortunately, the current practice, again, around, especially given the scale that we're operating on, we end up just dumping things from the web without, deep characterization of what's going on from the data. So it becomes a really problematic situation when the practitioners themselves have no idea what went into their models. So that's part of the reason I'm very big on characterization, very big on data selection, very big on tracing all of these things. That goes a long way to accountability and governance, but also transparency.
Yeah, so there's a question in the chat, and we'll end with this question that has to do with what is the necessary evaluation that has to occur at different levels in order to ensure that we're moving towards positive impact. So how do you see us actually gauging as a society that graph that you showed that, we want to see performance and positiveness go up as, efficiency or like cost is being addressed and is going down. But how do we actually know if that's happening?
This is a tough question. I don't know. So I think right now what we're doing is we're creating all kinds of benchmarks and we're creating all kinds of testing evaluation sets and what have you, thinking that and there are some talk about task-based evaluations. So, in situ, so to speak, you think about this as extrinsic evaluation of the models, like looking at the outcome at the very end. So there are different people, and I feel like as a field, we need to learn a lot from software engineering people working on these types of system evaluations. But again, if we, as a field, again, I think we need to also treat these systems as critical systems. So in the sense of we try to do as rigorous as possible types of testing and divide and conquer. So the difference between our types of systems like AI systems and, for example, medical devices or planes and so on, a lot of in our case, there's a lot of stochasticity. So this level of unpredictability makes it even more challenging. That's why I think it needs to be developed as a science as opposed to just, adopting from another field. So I feel like that intersection would be critical. But it's a tough question of where to apply all kinds of tests.
Well, thank you so much, Mona. You really gave us a lot to chew on, and I'm so glad that it's being recorded so people can go back and revisit it, and also that many who haven't been here today will be able to benefit from it going forward. So thank you so much. And I'll just now I will just conclude with a few concluding remarks. Since this is the last session of the summer events, I just want to acknowledge there's a huge number of people to whom I owe a huge thank you for their role in all of this. So I'd like to acknowledge my Dean, Marshall Hebert, and also all of the SCS department heads, and who I've enjoyed very much partnering with in this and also my past 2 years of interim department headedness. I'd like to thank all of our panelists and speakers for their contributions, for presentations, and also interacting with the community through Q&A. I'd like to thank the Block Center at CMU that is offering the prizes to our hackathon teams to help them to build out their ideas into real end user applications. And I thank them for their commitment to making this not just a hackathon that was, a short, a time of work, but into some real potential impact. I also like to thank our 4 GAI3 interns who worked all summer on their own generative AI research, but also prepared for the hackathons and were constant supports to the hackathon teams during those intensive weekends of work. We also had judges who were domain experts in our 3 impact areas, as well as technical experts. And I thank them for the time that they put into helping in the selection process. There are also several staff people who really gave tirelessly and helped to make sure that this all ran smoothly. And I want to mention some of them by name: Nicole Merritt, Jessica McGuire, Daniel Vossler, George Dracos, Mark Power, and Catherine Capitas for their contributions, great advice, and support along the way. And I want to thank Alex Nolte. He is the main organizer and runner of the 3 hackathons. He does research in hackathons, great insight into how to do it right. It was fun working with him. He worked very hard, and they would not have been nearly so successful without his help. So huge thank you from me to all of these and anyone who I may have inadvertently overlooked. It has been very rewarding to be part of this effort with all of you, and I couldn't have done it really without you. And now I just would like to say, as we're closing, we would love to hear your feedback on today's event, as well as this summer of events, as we are considering how to move forward with GAI3. We'll be taking a break, but we plan to come back with more events in the fall, and we'll be supporting our 3 winning teams throughout the year. And so at minimum, you'll be hearing some updates about how they move forward with their work, but we also plan some other events as well. So keep your eyes peeled, and you'll be hearing from us. So I believe Nicole is going to be entering the URL for our feedback form into the chat, because we really do want to hear from you. And I would say see you in October, when we will have some new GAI3 events. Thank you so much. And yeah, enjoy the rest of your summer.